Hello बच्चों, in today's lecture we are going to study a new chapter which is laws of motion. So the first topic in this chapter is types of forces. There are basically three types of forces which are commonly encountered in mechanics. It is field forces, that is, for example, we have gravitational force and electrostatic force. So gravitational force is the force. Uh, for example, if we drop a ball from our hand to the ground, then that is an example of gravitational attraction of the ball towards the earth. And electrostatic force is a force between two opposite charges or two uh, similar charges. Then we have contact forces. It is two bodies in contact exert equal and opposite force on each other. If the contact is frictionless, the contact force is perpendicular to the common surface and is known as normal reaction. The contact force between two objects is made up of two forces, normal reaction and force of friction. So we have, for example, two bodies here, A and B. One is kept over the another, and a force F1 is acting on body A and force F2 is acting on body B as shown here. Then the net force F is equals to n square plus frictional force F. So what is this frictional force F? That will be equal to, if we see this body here, if we see this body here, then this can be broken down into two bodies here, that is F1 and F2. So we have a body here in which A is shown here and normal reaction is upward, and the force F1 is acting in this direction, and normal reaction would be acting downwards on body B, and F2 is acting towards the left, and F friction force would be acting in this direction. Now attachment to another body. If a string is massless, tension will be same in it everywhere. So we have two bodies here, M1 and M2, which are connected through a string, through a pulley A. And if the string is massless, then the tension in it will be same everywhere. That is, T is equals to this T will be equal to this T. So that's the case here. And the next topic that we are going through is free body diagram. A free body diagram, FBD, consists of a diagrammatic representation of a single body or a subsystem of bodies isolated from its surroundings, showing all the forces acting on it. So we have two bodies here, M1, M and M, and so this is actually a book kept on a table. And what would be the free body diagram of this book? It would be the weight of the book acting downwards, that is W is equals to mg, and the normal reaction N, which would be acting upwards to counter the weight of the body, and it would be N would be in the upward direction. Now an example is there. A cylinder of weight W is resting on V groove as shown in figure. Draw its free body diagram. So we can see that there is a groove here. There is a groove here. This is a V groove on which a ball is kept here, and we have to draw its free body diagram. So we can see that the weight would be acting in this direction, mg in this direction, then a normal reaction would be acting in this direction, and another normal reaction would be acting in this direction, because there is a surface here. So a weight would be acting, a normal reaction would be acting in this direction. So we have the free body diagram of this ball as N1 towards the center, N2 towards the center, and W in the downward direction. So that was all for today, guys. If you have liked the video, please do like the video, subscribe to my channel, and share it among your friends. Thank you.